So today I'm going to show you, or this week, we're going to learn in class how to do factor label method. And we already have started some of this in class with the metric conversions, but I wanted to put more emphasis on this because this is a very good problem solving skill to have. So factor label, or dimensional analysis as we call it, is a process in which we solve word problems and we make sure we line up the units so they cancel out. So the setup is really important, and a lot of kids want to skip this step because they don't want to put in the units. But it's really important to put into units because then when you do so, it will all make sense. So I'm going to go through and show you how to set up the first couple problems. So the first problem says, how long is a football field in inches? So we know there's 100 yards in a football field. So there's some things we have to know first. So part of problem solving is understanding what we have, and then understanding what we got to get to. So we know we need to start with 100 yards because that's how big a football field is. And it's asking us to find inches. So that's what we have to end up with. So the plan is we have to go from yards to feet to inches. And most of you will be like, okay, well, I can do that in my head or my calculator, and I can set that up pretty easy in my head or in my calculator. I want you to be able to set it up on paper so you can see how the units cancel out. So if we look here, now some of these conversion factors you have to look up. So it's okay, use the internet to look them up if you don't know them. You won't be expected to know them. The only ones that you'll be expected to know are the ones like the metric system, what we've been learning, like 1 meter is 100 centimeters, 1 liter is 1,000 milliliters. Those things you're expected to know. So if we need to go from yards to feet, the conversion factor, you could look this up, but most kids know this, is 1 yard is equal to 3 feet. And the reason I put yards on the bottom is because I want yards to cancel out. A yard divides out a yard. So if you divide anything by itself, it becomes 1. So what I have left on top is a foot, which I need that unit because I need to get to inches. So then I need to come up with the other conversion factor. How many inches are in a foot? Well, we should know this, but if you don't, you can always look it up. 1 foot is 12 inches. So I put feet on the bottom, opposite of feet up here. If you can see there, I should probably put it in blue so you know I'm talking about, or darker purple. But they're across from each other, so they cancel out. So a foot cancels out a foot. So if you notice, I got yards to cancel out, I have feet to cancel out, and the only unit I have left is inches. And that's the one I want left. So now here's how we do the math. Well, if you divide anything by 1 or multiply anything by 1, it's itself. So I usually ignore the ones. So I have 100 times 3, which is 300. And then I have 300 times 12, which is 3,600 inches when I do the math. That's the unit I want left over. So the question is what about sig figs? Because you always, when you're solving these problems, you have to be aware of sig figs. Well, if you look over here, there's 1 significant figure in 100 yards. There's 2 significant figures in 3,600. So the question is how do I make that into 1 sig fig? Well, technically you'd have to round up and make that 4,000 inches to make it 1 sig fig. Yep, I know it's a lot of inches to round up, but if we're going by the rules of significant figures, that's what we'd have to round it to. So let's try another problem. So if a candy bar weighs 7.5 ounces, what would be the weight in pounds of 76.5 candy bars? Mr. Fletcher ate the other half of an ounce, which is, we don't need to worry about that. So I like to come up with my conversion factors by reading the problem, because sometimes the problem has it for you. But let's figure out what we're given here. So we have 76.5 candy bars, and I'm gonna put CB for candy bars. And I need to go from candy bars to pounds. So I need to go from candy bars to ounces. So candy bar to ounces to pounds. Okay, so if you look here, it said a candy bar weighs 7.5 ounces. You might not realize it, but that's a conversion factor for you. So you can say 1 candy bar is equal to 7.5 ounces. So what I'm going to do is I need candy bars to cancel out. So I am going to say 1 candy bar is 7.5 ounces. So what's going to cancel out? Your candy bars will cancel out. And what do I have left is ounces. Well, I'm not done yet because I need to get to pounds. So then what I'm going to do, let me use another color. I need ounces to cancel out. So this is the conversion factor I'm going to use here. 16 ounces is 1 pound. So what cancels out? Ounces divides out an ounce. So the only thing we have left to do is do the math. So what's the math? So we have to take 75.5 times 7.5. So 75.5. So 75.5 times 7.5 divided by, because if you notice, 16 ounces in the denominator. So then you're going to have to divide by 16. So divided by 16. So if I have 3 sig figs in 75.5, my calculator answer is 35.3906. Well, I only need 3 sig figs, so my sig figs are going to be 35.4 pounds. That's how many pounds 76.5 candy bars are. That's your answer. Let's do another one. Let's do, how many minutes are in July? So we know there's 31 days in July. So 31 days. So you could do this several ways. However, I'm going to go from days to hours, hours to minutes. So 1 day is 24 hours. And then 1 hour is 60 minutes. That's not difficult. I get that. What we want to show is our units cancel out. So days cancels each other out. Day divided by day. And then hours divides out an hour. So when I do the math, 31 times 24 times 60. So if you look here, you have 2 sig figs. In my calculator, I get 44,000, and you should be practicing this in your calculator. You get 44,640 minutes. Well, I need that to be 2 sig figs. So you could do it this way. 4.5 times 10 to the 4 minutes. That would be your correct sig figs. So let's, I don't know, let's move around. Ooh, let's do some metric. So I have 320 centimeters and I want to go to kilometers. So we did a little bit of this in class. So remember the saying, King Henry died by drinking chocolate milk. So kila, hecta, deca, base, deci, centi, milli. So we're in a centimeter and we need to go to a kilometer. So we could do this in one step. So you could say, if I have 1 centimeter and I need to move my decimal 1, 2, 3, 4, 5. I need to move it 5 places to the left. So it'd be 0.00001 kilometers. So when I do the math, so now I'm going from a centi to a kilometer. So what that should say is if I take 320 times 0.00001, I should get you should get 0.0032 kilometers. Now, 2 sig figs over here, 2 sig figs here. So your answer is correct. Let's go back up to 4. So it says if you buy 3.47 pounds of ground beef and you made each burger 3 ounces, how many burgers can you make? So let's first, you're going from pounds to the number of burgers. So I want to say number of pounds to number of burgers. So, and we know that according to the problem, each burger is 3 ounces. So 1 burger is equal to 3 ounces. So if I have 3.47 pounds, I need to get rid of pounds. So you need to ask yourself, well, how many pounds are in an ounce? Well, if you go back up to problem 2, it'll tell you that there are, in 1 pound, 16 ounces. Why did I put pounds on the bottom? I put pounds on the bottom because I wanted it to cancel out. So I go from pounds to ounces, and then I'm going to make a 3 ounce burger. So 3 ounces is equal to 1 burger. So what cancels out? Ounces cancels out an ounce. So if I'm doing the math here, 3.47 times 16 divided by 3. So if we look at sig figs, I have 3 significant figures. So we can make 18.5 burgers out of 3.47 pounds. Okay, let's see what else we have. We'll practice a few more. Let's try something where we have 2 units. So if I am walking four miles per hour, how many feet per second does that equal? So what's different is now we have 2 units. And 2 units is I have miles per, so this division line means per. These are both division lines. So miles per hour and feet per second. So miles is in the numerator and hours is in the denominator. So we need to convert both of them. So I suggest you convert them one at a time. So we're going to go from miles to feet, and then we're going to go from hours to seconds. So I'm starting with 4 miles per hour. Now, I'm going to go from miles to feet. So what do we need to know? We need, and we talked about this in class the other day, 1 mile is equal to 5,280 feet. So I'm going to put 1 mile on the bottom because I want it to cancel out. And then I'm going to say 5,280 feet. So then miles cancels out a mile. So now I have feet per hour. Well, I don't want feet per hour. I want feet per second. So next what I have to do is convert hours to seconds. Well, how do I do that? Well, an hour is down here, so I need to put 1 hour up in the numerator, and I'm going to put 60 minutes in the denominator. So hours cancels out an hour. So now I have feet per minute. Well, I don't want feet per minute. I want feet per second. So then I need to do one more step. I got to get rid of minutes. So 1 minute is 60 seconds. So that means minutes cancel out a minute. And what am I left with? I'm left with seconds. So I have feet per second. So now let's just do the math, which is pretty simple. You're going to take 4 times 5,280. Now, 60 is in the denominator, so if you have anything in the denominator, you're going to divide by 60. So you're going to divide by 60, and then you're going to divide by 60 again. So what is my answer? 1 sig fig is 4, so I'm going to take, my calculator answer is 5.8 feet per second, but I only need 1 sig fig, so I'm going to round it up to 6 feet per second, and that's the answer. So this is just a few dimensional analysis problems. We will actually practice more of them in class. So take good notes, practice this, and do your homework. And then if you have any questions, we'll talk about the rest of this in class.